polar function r equals sine of 2 theta if you graph it and have theta go from 0 to 2 pi, then we get these 4 petals. So the idea is to find the area of one petal. So if the whole graph goes from 0 to 2 pi, and we only want one of the 4 petals, then we should be able to divide this by 4 and have theta go between 0 and pi over 2. Now sometimes this idea works out perfectly and it would just give us one petal like this. Sometimes what it'll do is give you half of one petal, let's say half of this one, and then the other half of this one, so you have to make adjustments. Let's see what happens. So with this one, have it go from 0 to pi over 2, and that works perfectly. So integrate. The formula for area in polar form is that it's 1/2 r squared d theta. And then we're going to be integrating this one from 0 to pi over 2. So integrate 1/2 r squared, and for us r is sine of 2 theta, going from 0 to pi over 2. So we could factor out the 1/2, and then in order to integrate sine squared, we need to use the identity that sine squared is equal to 1 minus cosine 2 times the angle divided by 2. So we've got the 1/2 factored out, integrate 1 minus cosine of 2 theta over 2 replaces the sine squared, and then the limits. And what I'm going to do next is go ahead and factor this 2 out, so this is actually going to become 1/4. And once that's gone, then just integrate a 1 with respect to theta is theta. And now integrate negative cosine of 2 theta, so that's going to be negative sine of 2 theta. And then you have to use the chain rule. The derivative of the inside is at 2, so divide by 2. Then 0 to pi over 2. So substitute the pi over 2 first of all, and that's going to be pi over 2 minus sine. When you substitute a pi over 2 right here, the 2's are actually going to cancel, so you get sine of pi. And sine of pi is actually 0, so this isn't going to actually contribute anything. Next, put a 0 here and a 0 here. Well, sine of 0 is 0, so that's actually contributing nothing as well. So all we really have is the 1/4 times the pi over 2, which is going to be pi over 8. Is it possible to use the graphing calculator to check like we can do so many times? Let's see, if you go to second calculate, all they have in this calculator are some derivatives. They don't have integration. So we just have to say, I must have gotten it right.